Good morning, student. In this session, we will start with the power screws. Before starting the power screws, we must understand the meaning of power screws. The screws which are used to transmit power are known as power screws. In power screws, the rotary motion is converted into linear motion, or rotary motion is converted into translatory motion. Just we take the example of lead screw in lathe. In the lathe, rotary motion is available and that is converted into linear or translatory motion of the tool. Now take the example of screw jack. In screw jack, we apply the force in horizontal plane and the screw moves in vertical direction, upward or downward, which is used to lift or lower down the heavy loads. Now take the examples of the press, C-clamps or machine vice. In that we use the power screw for power transmission. Power screws. Power screws means translation screws. They are also known as translation screws, are used to convert rotary motion into linear motion or translatory motion to transmit power. For example, first, in case of lathe, the lead screw, the rotary motion is available, but the tool has to be advanced axially in the direction of cut against cutting resistance of material. Second example, in screw jack, a small force is applied in horizontal plane is used to raise or lower large load. Third, power screws are also used in machine vice, testing machines and press, etc. Now we will see different devices where power screws are used. First is screw jack to raise a load, lead screw of lathe to have accurate motion in machine operation. Third, vice to clamp workpiece. Fourth, universal testing machine to load specimen. Terminology used in power screws. The terminology used in power screws are major diameter, it is also known as nominal diameter, mean effective diameter and core diameter, pitch, helix angle and lead. Now we will study one by one. What is nominal or outer or major diameter? The largest diameter of the screw is known as major, nominal or outside diameter of the screw. Let us see the definition. Nominal diameter. It is defined as the largest diameter of the screw. It is also called as major diameter of screw. It is denoted by letter DO. So this is the outermost or maximum diameter of the screw. So this will be known as the major diameter or nominal diameter or outside diameter of the screw and denoted by letter DO. Now next is the core diameter. It is also called as minor diameter. It is denoted by letter DC. So these are the roots of the threads. So this diameter is known as root diameter or core diameter of the screw. This is the smallest diameter of the screw. Next is pitch. It is defined as the axial distance from one point on one thread to the corresponding point on adjacent thread, measured parallel to the thread axis. It is denoted by letter P, small p. For square thread, DC is equal to DO minus pitch or DO is equal to DC plus pitch. Now pitch is defined as one point on the thread and next point on the adjacent thread or corresponding point on the adjacent thread. This actual distance is known as pitch. Mean diameter or mean effective diameter. It is the average of nominal diameter DO and core diameter DC. It is also known as pitch diameter. It is denoted by letter D. Mathematically, mean diameter is equal to D equal to DO plus DC by 2. Lead. It is defined as the distance through which a screw advances actually in one revolution of nut. Suppose this is a nut and this is screw, and in one revolution the advancement of the screw is known as lead. For single start thread, lead is equal to or pitch is equal to lead or lead is equal to pitch. For multiple start thread, lead is equal to number of start into pitch. Now we will see it is denoted by letter L. For single start thread, L is equal to pitch. For multiple start thread, lead is equal to number of start into pitch, or L is equal to N into P. Now helix angle. It is the angle defined as the angle made by helix of the thread with a plane perpendicular to the axis of screw. It is also known as lead angle. Mathematically, it is tan alpha, that is equal to lead upon pi d, where d is the mean effective diameter. Helix angle. This is the perpendicular plane. This is a plane which is perpendicular to the screw, and this plane makes an angle with threads. This angle is known as helix angle. Now different power screws profile. The different power screws profiles used are square, trapezoidal or acme, buttress and knuckle. Now basic profile is square profile, and these are all modifications of the square, or it is the combination, or acme is the combination of the square and V thread. This is also combination of square and V thread, and it is a modification of square thread. Now square thread, here thread angle is 90 and comparatively weaker than the V thread. Power, it transmit power at low speed. It can transmit power in both the directions of the axis. Second is trapezoidal or acme thread. The difference between trapezoidal and acme thread is only in the depth and thread angle. In acme, thread angle is 29 and depth is more, and in trapezoidal thread the thread angle is 30 and depth is less. So they are comparatively strong, and because at the base it is the combination of V and square thread. At the base, the base is larger for high power transmission at high speed. It is used to transmit power in both the directions of the screw axis. Now third is buttress thread. It is comparatively strong, and it is the combination of square thread and V thread. Here thread angle is 45 degrees, and it is generally used in power press. It is used for moderate power. Now next is the knuckle thread. It is strong. It is the modification of square thread. It is used for high power at high speed. So these are the different profiles used in power transmissions. Thank you very much. This is the end of the session.